Engineering with Inceptra, and I will be moderating today's session, and we'll introduce our speaker for the presentation, SIMULIA in the 3D Experience platform, in just a moment. But first, please let me remind you that as a courtesy to others, all attendees have been placed in listen-only mode. At the end of the presentation, we will be opening up the floor for a live Q&A session as time allows. However, we do also encourage you to send us your questions and comments at any time during the presentation using the GoToWebinar questions panel, which you will find in the same dialog as your GoToWebinar controls. You have the choice of submitting them publicly for all attendees to see, or if you prefer to hold a private conversation, please feel free to send them directly to the organizers and panelists. Our speaker for today, Todd Wigglesworth, is a senior application engineer from Inceptra with nearly 20 years of experience keeping on top of the evolving CAD, CAM, CAE technologies, and has helped companies of all sizes discover innovative solutions to their challenges, like the one we're going to take a look at today. So we appreciate that you have taken the time to join us, and without further ado, I will now turn it over to Todd, who will begin our presentation of SIMULIA in the 3D Experience platform. Todd?
Thanks, Jason. Thanks for the introduction. Welcome, everyone. Today's agenda is around 3D Experience, specifically for SIMULIA or Abacus. The agenda for today, first off, I'm just going to give a brief history of, CATIA and Abacus and where it's come from and where it's going. And then we'll talk just briefly about 3D Experience and the values that come because of that. And then we'll touch on SIMULIA and some of the capabilities. And I'll basically be doing, there's 3 main live demonstrations I'll do today, all centered around 3D Experience and SIMULIA. Then we'll get to the key messages, and at the end, we'll have a quick question and answer period where it's at that time, as Jason mentioned, you guys can feel free to ask questions. We will introduce a couple polls throughout the session as well, and we're going to do one here just to engage you as an audience here right at the very beginning. So with that, the first poll question, which Jason will moderate and explain how to answer, is what are you currently using simulation for today? Jason?
Yeah, thanks. So if everyone could please take a quick second and submit their response to this. We'll keep this poll open for just about 20 seconds or so we can collect the responses, and then we'll share that with everybody. Okay, and we'll go ahead and close this poll, and then I'll share the results. So thank you for your responses.
All right, thank you, Jason. So a little history with regards to, where this technology's come from and where it's going to. So if we kind of go back to all the way back to 1998, that is actually when CATIA V5 was introduced. Windows-based parametric modeling from Dassault Systèmes. And that's what many of us are using today from a CAD standpoint in different industries, icon-based and what we're familiar with. And as well, back in 1998, we also had Abacus. This is Abacus Pre, version about 5.4. And, 2 of the best in-class technologies, at the time and as well today, but 2 totally different geometry kernels and interfaces, which can cause havoc when transferring the information between the 2. So let's fast forward to 2007. And when I say 2007, I mean, yeah, like that long ago. That was when the first introduction, if you can believe it, of CATIA V6 existed. And we got our first copy actually at Inceptra and installed it. CAD on, the cloud, well, basically CAD going to be evolving to be on the cloud, database driven with TLM, no files. Again, the interface was slightly different, icon-based, but still very familiar to a CATIA user. But the interface for SIMULIA back then in V6 was slightly different. They kind of evolved it. They added some Abacus functionality inside of the CATIA world. But the interfaces still were different from a standpoint of a CAD person or an analyst or maybe a marketing or someone in sales. If they wanted to access this data, everyone had a different look and different idea of the way the interface looked. So let's go to 2014. That was last year. That was the first year that 3D Experience was introduced. So we're now at 2015X, which was released, I don't know, about a month ago, I would say. And this is the interface of Abacus or SIMULIA inside a 3D experience. It's very streamlined. You know, as you can see here, it's kind of hard to tell you're even in Abacus or in CATIA. And I actually just changed slides. You probably never even noticed. But now I'm inside a CATIA. And now I'm inside of a CATIA, another CATIA application. And there were some slight changes, but really all that's changing is the name of the workbench or the app we're in, and the action bar down below, which give us our tools and functions that allow us to work day to day. I just changed again. This would be the view of someone from that doesn't run CAD or analysis and basically wants to work in PLM. Again, it looks the same look and feel across all platform, all applications and all people in the company. So here you're seeing all those four side by side, and really the differences again are the app or the workbench we're in, and the action bars that are at the bottom that give us our tools, you know, assembly tools, analysis tools, things like, you know, the users need to access. So just a quick overview of what the interface looks like, because when I demo today, I'll be showing you these how to you know, use some of these different tools. And what we have here in the top left is what we call our 3D compass. It's got different quadrants. The west quadrant is our 3D modeling quadrant. That's where you're going to access the applications for you know, 3D modeling. And in the bottom, which is the focus today, is V+R, virtual plus reality. That's where the apps are going to be for Abacus. Okay. And then we also have up in the top this search tool, search bar. We can produce or create 3D searches, and we can also filter using more, you know, modern internet-based search tools such as tagging. So everything in the database is tagged. It's very easy to filter a very large, you know, search results down just by using the tags. We typically would, you know, use to filter our photos day to day, in like, you know, on our, you know, on the cloud and things like that. There's also over on the right here just some general toolbars, information about you as a user, who you're logged in as, area to add content, create objects, share content, save, export back to V5, whatever, and also a home and a help tab. So this is a completely consistent interface, not across just the SICK client or the CATIA workstation or Abacus, you know, user, but also across the web client as well, which I won't be showing today, but the web is identical to this in the way it looks and feels. We also have down in the bottom, this is most important for Abacus users, is the action bar. This is where we're going to do our meshing, you know, create our cases, and basically access everything we need to do to set up and execute and visualize the simulation. So with that, what I want to do is I want to share a video that was played at last year's SIMULIA community conference, just to give, you know, anyone that's familiar with Abacus and, you know, where that was. This just gives you a good idea of where everything is going and why you need to be excited, because, you know, not only Abacus, you know, there's limitations, I guess, once, you know, you can only evolve the technology, you know, so much if it's not modern enough. And it goes the same with V5. There's new stuff in CATIA V6. There's new stuff in Abacus V6 that we can't evolve in the older technology. And that's what this video kind of shows. so that's a little glimpse in some of what I'll be showing in the demo as well, just some of the look and feel of how 3D Experience looks. But we'll just start off with just some of the key values that it brings to the table. So number one, and I kind of highlighted this already, is just unified user experience across every role, everyone in your company, from sales through to marketing, engineering, manufacturing, shop floor. Everyone has the same look and feel and can talk on the same, level and interface. Something that's really changed a lot is that the packaging now is based on what customer needs in each individual industry. So if you have a mechanical engineer in like aerospace versus consumer products, they will be packaged with the right pieces and tools to kind of get the job done, no matter what. So you're not going to just have a mechanical seat in aero, a mechanical and consumer product. They're going to look totally different and be arranged properly so that they have the right stuff and don't have to add on anything special. We also want to, an extension to any discipline, we really want to make sure that this tool is available to everyone, and everyone's looking at the same single source of truth and grabbing the same information that's out of the database, and everything is up to date. And there's other key values. I mean, the middle one for us is Inceptra, is just designed to be on the cloud. We have a lot of small customers that only need, 1 or 2 seats of this type of technology. And because we can deploy it from a cloud solution, that means that they can avoid the whole IT setup and that situation. And there's pieces of Abacus that are already available on the cloud, and we can sell to our customers today. So the core technology from an Abacus standpoint, this slide really, when I heard this from Dassault, this is something that got me really excited, because I didn't think it would be able to go this way. But I want to point out that all the core technology from the Abacus standpoint, which is, the solvers, that's the real heart of Abacus, the standard solver, the explicit solver, and the newer like CFD solver. All these solvers are what are being used in 3D Experience. So what I mean by that is, and what's important here is that we're not recreating new solvers in 3D Experience. If you're using the older Abacus CAE or 3D Experience, it's the same solver technology being developed only once and being used in both technologies, which becomes very important. We don't want to have to create new solvers or Dassault to create new solvers in 3D Experience, because it takes away from the development of enhancements that we want, at both CAE level and the newer V6 level. Also, if you take a look at the history of what Dassault has done from a simulation standpoint, it's probably the most committed brand, like, from an engineering or analyst standpoint, the most committed brand when it comes to acquisitions. When Abacus was acquired in 2005, that was a big time for Dassault, because we finally had something that wasn't just a CATIA-based analysis, but we had a proven technology from the market. And over the years, and I'm not showing all of them, they've acquired other technologies such as, Tosca for optimization, EyeSight again for parametric optimization, FE-Safe for fatigue and durability, Simpo is a newer one for plastic injection. And already in 2015, we're seeing pieces of these technologies appear in 3D Experience as apps. And I'll mention one of them here today shortly. So SIMULIA key values. Integrated architecture, this is something that is huge, is to be able to be in CATIA and Abacus at the same, engine, the geometry engine, and be able to just make changes and updates. So we truly have an integrated architecture in 3D Experience between CATIA and SIMULIA and some of the other brands. It's unified. We've gone over that already on a few slides. We're integrating into the architecture other domains. So all the technology from a CATIA analysis standpoint is there in certain apps, as well as we're starting to see Simpo for plastic injection, FE-Safe, and EyeSight apps and other things be integrated as well and exist. It's being packaged by role, so that if you're a designer, there'll be roles that are custom, structural analysis for designers, and there'll be ones for analysts, for CFD analysts, or for composites analysts. And in the demos today, you'll see what I mean by that. They look and feel a little different as well in the way the user interacts with the interface. And then finally, discipline interoperability. So, not only will analysts and engineer run analysis, look at results, but C-level project managers, they're going to be able to access the information as well. One of the real cool things is there's this 3D Play app that allows, people on their iPad to actually open up simulation results and look at results and what was already created. This might be something the C-level or the CEO, someone that's going on a sales call very high up, maybe able to take that out to a customer and take it out on their iPad, access the information, and show even simulation information. So that brings us to our second poll of the day, second and final poll. What would you like to do to advance your simulations in the future? And Jason, if you could take that on for me, that'd be great.
Absolutely. Yeah, so if everyone could please take another quick second to submit a response here. And again, we'll leave this poll open for just another couple of seconds while we collect the results. And thank you, everyone. I see the results coming in right now. Excellent. Looks like a very large interest in composites, as well as maybe some of these other areas like durability, fatigue, and optimization.
Okay. Thank you, Jason. Thanks, everyone. So let's get to the point where we get to see some technology. And so what I'll do is I have 4 areas that I want to kind of touch base on. Different, almost like different roles in the company. So if you were like a stress engineer that wanted to do some preliminary analysis up front, just to basically, size up a design and make some changes early on in the design process. There's capabilities through different apps to give you the ability to do structural strength, frequency, thermal, and life durability or like fatigue. So all available in 2015X. The key values for that are, again, you get state-of-the-art Abacus technology embedded basically in your CATIA environment. And it's going to help foster and encourage you to be able to make changes or optimize the design early on in the design process. And one of the best things about it is you're actually going to be running Abacus solvers in the background as well as the meshing through an adaptive meshing technique. And it's available on-premise, meaning you can have your own database like on-site at your own company, or it can run on the cloud as well. So this is what it would look like from a stress engineer's standpoint in 3D Experience. If you have a product or a part and you want to run an analysis, you're going to be presented with this simulation panel. It basically is a wizard that's going to walk you through the stages of setting up and executing your simulation. You also have this thing called the assistant. It's almost like your help tutorial, but it's interactively changing as you go through the process of staging your simulation. Not only does it tell you and give you help, but you'll see that you can actually interact with this panel or this assistant as well. And then finally, if you don't want to just follow the wizard, you can access the action bar, which gives you access to all the functionality from the stress engineer standpoint. This action bar, if you're an analyst running, Abacus day to day, you're probably going to avoid these wizards, which are in some of these applications, and you're just going to use the action bar day to day. It's like your icons or your toolbars that you would be familiar with in a CATIA or Abacus environment. So with that, let me jump over into 3D Experience and just show you a quick demo here from a structural standpoint. So this is my 3D Experience interface. You can see I've got that compass here. If I go onto the 3D tab, I have my favorite apps here, part design, assembly design. They're just like workbenches in CATIA for modeling and stuff like that, composite. The V plus R, I have my, I didn't create any favorites, but I do have like all my simulation apps available here. Things like, fluid dynamics, durability, structural validation, those types of things. So what I'm going to do is I'm just going to search on a product here, and we'll take and we'll open up this medication reminder. So what I have here is just this medication reminder. It's a two-part assembly. It's like it holds those blister packs of medication. And you can see I have it up on the screen. And then I have that familiar tree. You know, it looks a little different than Casilla, a little different than the Abacus model tree, but it's here contains, you know, all the part information, including the features, so that I could make changes or run, you know, optimizations and things like that. Also, actually, underneath here, I've got my materials associated. So if I activate my material cards, you'll see here I have, similar to what an Abacus user would be used to, I have all the information here to define my different materials, you know, density, elastic, plasticity, very similar to what you'd be used to in Abacus. And actually, you can just load these in from Abacus if you had to, and they would write themselves right into the database in this form. So as a designer, if I wanted to run a quick simulation, you know, what I would do is I would go into my V+R tab and run, you know, structural validation. I'd have access to that app. And in here, what I have is, you know, I'll just do a structural analysis. And at that point, what it does is it actually creates a simulation object and presents to me over here in the wizard. So this wizard, you can use the action bars to get to everything that, you know, runs you through on the wizard, but for the most part, you can get the job done by just filling in the blanks. Check marks are, you know, what's done and completed. These, like contact, need to be applied, the red circle, and this simulation results are X'd out because I don't have enough information to produce that. But if I go into part, you'll notice that it will show me in the assistant, it shows me, you know, what icons I would have available. So like, for example, contributing parts, if this was like a 20-part assembly and I only want to run it on the top part, you know, you can disable them. You don't have to remove them from your assembly if you want. I've got my materials, and it already knows there's a material in those part files I had there, so it's got a check mark. I've got my contact, and these are going to look like, you know, contact detection, general things you'd be used to seeing in Abacus. We can set up tie constraints. I'm just going to do this, it's called contact detection. And if I do a quick find surface pairs, it will, within a certain tolerance, identify the surface pairs that match up and the faces and associate them to like a bonded like tie constraint. So I've kind of accepted and I've added in that contact. I go to restraints. And again, if I go down to the toolbar down here, I've got my restraints, you know, clamps, planar symmetries. So I'll just do a clamp, grab some faces, and you'll notice that it creates these nice glyphs. They call them glyphs. They're just like where it highlights the surfaces and creates features. And you can extract, you know, tangentially and things like that. There's different tools based on face angle and stuff. They've added those in, sort of like the way you do it in Abacus. And that actually ends up being a feature. So if I double click on it, I can come back into it. And, you know, if I go into this simulation manager, all this stuff's being captured up here as well. So this is my clamp, my bonded contact. So there's ways to get to them in a list as well if needed. So let's go ahead and add in a load condition. So let's put in like a remote force, pick on a face, use my robot to manipulate it, put in 100 newtons. And at that point, what you'll see here is that I've got my load, I've got a green light that I can actually go to do a simulation. So I have different accuracies I can do. Basically, the number of times it will remesh to improve accuracy or adapt the mesh. I can do a quick draft and get a result. And you can do this interactively with various numbers of cores. You can do it interactively or detach it, meaning I can run it in the background and then continue to work. And then the PLM system will flag me with a notification when the job has been executed. So I can go open up the results. So it's going to take a couple minutes to run that. So I'll just open up a completed simulation and just show you what the results look like. So we'll go to the Results tab, click the Visualize. And you can see, I can see a displacement right now, and we can use our compass up here to basically play back the simulation. So I'll just set the number of frames I want to see. I'll go 100. And then we can play back the simulation here dynamically on the screen. Now, whatever I do here in this structural simulation app, this structural validation, this model is fully accessible by the advanced analysts. Like this data, it's all one data set. If I want to get in and add in some very complicated, additional information or scenarios, I'll be able to do that with this data model I've created, because it's kind of driven it through. It's driven the designer to create this analysis using a wizard, but in the end, everything is here from the high-end analyst standpoint. I've got my model, I've got my scenario that's been set up, and my results, and all this can be accessed here from the tree or from an analyst standpoint. So I can also hover over, take a look at what's going on at certain probe different points, and then I have other results I can look at here, things like factor of safety, yielding, simulation accuracy, von Mises stress. So I can see, the von Mises stress. And if I click on the model, it'll come up with other options such as like show all the maximum stresses here. You can see there's the global max, the global min, or both of them at the same time. I'll clear that. We can also, do cut sections using the robot and just cut dynamic sections. Let's hide the cut. I meant to hide the cut plane there. Let's do, yeah, there we go. So we can cut through and dynamically see that. So let's clear that. And then finally, it creates some really nice, it has some really nice reporting capabilities. If I create a report right now, it actually knows there's a report already in the PLM database. Actually, when you create a report, it automatically tags it to this simulation and drops it linked to the simulation into the database. I'm going to retrieve the existing one instead of creating it. And you'll see here that, you've got a very nice, concise report. And it has fields. When you set it, when you do your first report, you'll be able to set up, your username, logo, and everything for the header of the report. So that's a quick overview of the structural validation inside of 3DEXPERIENCE. So let me just jump back to the presentation, and we'll push on a little further to a different section here. So something that is newly introduced in 2015X is the ability to do plastic part design and filling. So SIMPO, which was acquired specifically for plastic part injection simulation, has delivered an app inside of 2015X from a part designer level to do that type of simulation. So the key values here are, we now have inside of 3DEXPERIENCE the ability to do plastic injection directly coupled with the CAD model at any time. Make changes to the CAD model, update the simulation results, thermoplastic parts. There's an extensive material database that's been brought along from SIMPO that's part of the 3DEXPERIENCE installation. And we can set up injection locations and some default machine settings and mesh, and also refine the mesh. We'll be able to see the mesh, refine it in different areas, and run that injection simulation to see things like fill time, pressure front, get your sink marks, weld lines, air traps, and just see if you're going to be able to actually even fill the part to begin with. So that's a nice new application. And again, it's It's driven from a designer or engineering standpoint from this wizard approach. We have a part on the screen, and we go through, define materials, set up the simulation and injection locations, and mesh, and then simulate and solve it in the background, as you can see here. Another role you can have is fluid mechanics. So from a fluid mechanics standpoint or CFD standpoint, this has existed back in the first release of 3DEXPERIENCE, but it's been fairly well enhanced. We have the CFD coupled to the design environment or CATIA. Some of the meshing capabilities, it's new. And the way it meshes, I'll show you here in the demo, it's pretty exciting, the number of elements we can create, and we can thread it across multiple cores, as well as the high performance visualization and how we can post-process and see the data. It performs so much better in 3DEXPERIENCE from a graphics and performance standpoint. So we're supporting steady state solver, transient, and incompressible flow. I mean, we can set up some turbulence modeling and then boundary layer meshing and things like that. I think the best way to show you this is to, again, do a quick demo of the CFD interface. So we do have a guided workflow approach for the engineer who doesn't know maybe everything about CFD. We have that wizard-based approach, but in the demonstration, I'm going to kind of do it from an analyst standpoint and avoid this wizard and show you how to use the action bar to produce what you need to do. Let me drop out of this slide here. We'll come back. So we'll open up this pipe assembly. I don't know, there's a number of different parts here. Something we do an internal flow, simulation on, where we'd have, this would be 2 inlets and an outlet, and there'd be some kind of mixing, and we want to study that. So we have an assembly on the screen here. Again, the material property part, we'd fill that in for fluids like viscosity, thermal information, specific heat. You'd have to have enough information in your properties here. And again, there's a database that comes for some of the default fluids you typically use. So if we did want to do a simulation, a CFD simulation, again, we're going to go to V+R, and we're going to set up, and we're going to do what's called a fluid scenario. So once we get inside the fluid scenario app, as an analyst, I'm not going to be using the wizard typically. I'm going to be using a lot of the different functions that I'll see through different apps down here in my action bar. The first thing I need to do, though, is I need to set up my finite element model. So what this is inside that assembly, I'm going to set up what's going to be meshed, as well as the properties or the section properties that are associated to the fluid. So in here, what I'll do is I've set that up. And then what I can do next is then go over into the modeling app and create my mesh. Let's go actually back to the modeling app first, and let's set up actually my fluid domain. So in here, what I'll do is I need to define where the fluid's going to be. So I'm going to just grab all my parts, grab those. And we need to determine if it's an internal or an external fluid. So it's kind of the two possibilities. So if I did choose external, which this isn't, I can come down into boundaries here and say, set up a bounding box. So if it was like a vehicle or something, we could set up and just quickly define a bounding box that would define our fluid domain around the exterior of the part. But I'm going to go internal here. And instead of trying to capture an actual solid or surface model of the internal region, I can extract it just through defining regions in the inlets and outlets. So what I can do first is, from a region standpoint, I just need to pick one of the internal surfaces that defines the direction of where the fluid is. So I know it's inside on that side, positive side of that surface. And then I can capture where the fluid terminates by setting up the inlets and outlets. So I'm going to go ahead and just define that as an inlet. Define this as an inlet. And then this one, this will be an outlet, so we'll just define that. And it's almost like just going to terminate, it's like I'm going to extract from that internal surface and then terminate where those outlets are going to be. So that's going to define my, what we call my fluid domain. And then once I have that, I can define my fluid section. So if I choose that glyph that defines the domain there, it'll automatically know there's water associated to that assembly, and now I have my section properties for the fluid. As you can see here, it's created them here in the tree. So once I've done that, I have something to mesh. That's where I would go now into my meshing app. So in the meshing app, I have access to all the different meshing techniques here, but the one specific to this that I typically is this hex-dominated meshing technique for CFD. So it's figured out my fluid domain, and then I can set up a maximum, minimum size, angle between faces, and most importantly, I can set up this boundary layer, number of boundary layers at the boundary of the fluid, and then the thickness as well. And I can thread this across multiple cores, push that to a remote host if I have that set up. And also, in some cases, you may want to define, finer mesh or coarser mesh in certain regions, and I can do that. So I can mesh this right here on my laptop, and it's like, 190,000 cells are, being created, and it will quickly mesh that using 4 cores to come back with a quick representation of a mesh. We'll let that finish, and you can kind of see a preview of it there terminated on the end with those boundary layers that I created. So let me go into visualize, and there's little hide tools here, and I'll hide the assembly. And then we can go through, and let's just do we can section this to take a look at it. You can see I can also cut it off here, so you can see it's just sectioning through. And you can do there's checks here, so you can do a mesh quality check. And different tools to edit the mesh and things like that. So I'm going to cancel out of the mesh tool here. All right, so we have it meshed. So now we can get into setting up our scenario. So I'll go back to modeling and go into scenario. And so from a procedure standpoint, I need to define the physics model. So in this case here, it's going to be a fluid. And it's going to be we're going to do an incompressible steady state flow step with, I'll just leave it at 2,000 increments, iterations, okay? And we can set up other conditions. There can be, initial densities, velocities, initial temperature of the fluid. You can set it to be 300 K. Set up interactions. We can set up how the flow is going to be, starting. So in this case here, we can actually set up wall conditions where there's slip or no slip as well. And in this case here, let's just set up some initial velocities. So on that inlet, we've got it set at 1 meter per second and a temperature of 300 degree Kelvin. And then on this inlet, let's go at, 2 meters per second and 350. So there's going to be some speed difference and temperature difference. And then on the outlet, we'll put in just a pressure outlet. We'll leave it at static pressure. And we've got this option to prevent recirculation. So, that would be, a pretty simple setup. And at this point, I could, go through and run the simulation. Again, you have this simulate tab. You can run multiple cores. This is the adaptivity, different levels of what we're going to check for just as we execute. I'm not going to run this because it's going to take 10 minutes or something. So we'll just open up another model here that has the completed results. So we'll close out of here. and go to the results app. So you see we set up 200 increments, or I guess I did 200 increments. These are the different increments here. This is a temperature plot. I've got it sectioned. So these would be the increments as it progressed, right? So if I go to the end when I'm achieving, like, I guess, steady state, then we have the different temperatures across that section. So you can see, remember, we came in at 300. I guess on this simulation I set it up at 350, and then we had that mixing. It's coming out at, probing at, 324, okay? More available than this. But if we take a look at, say, velocity, you can see that there's that, remember, we had, what, 1 coming in. I have 1 and 1 on this one, and then there's like this area here where there's not a lot going on. There must be some vortices there. And then down here we have the outlet. So we can see the different velocities. And let me turn that section off. Let's go to disable the section. And this is an interesting plot as well, is the ability to create these, what we call streamlines. So we can pick certain particles or areas in the simulation and plot to follow those particles through the simulation. So in this case here, I'll just say, all right, plot 5 streamlines, and we'll do them as, we're going to plot them based on color, downstream and upstream. If I hit apply here, I end up with these streamlines colored based on the velocity plot, and you can see the particles where they're going, right? So then let's do another one up on the top here. This is it's pretty cool to do this when you're doing like an external flow around some object, because you'll get like it, in the wake and stuff. You'll get some pretty cool action with the particles. So we'll go up here and we'll do 5 across the top. You can see them coming down. And if I go back to the simulation manager, remember, everything's getting captured up here. So all those initial setups I did, initial temperature, these features are getting captured here. And I also have, because I'm in results mode, I also have the option to go into my outputs. Let me just flick back to the scenario tab here. I don't want to go into field. I want to go into history. Yeah, it's this one here. This will be familiar to an Abacus user, the variables or the field outputs. So these are the ones I can choose to output. If I was in a stress simulation, I'd see a lot different options here, but because I'm in CFD, this is what I'm seeing. I'm choosing to be able to like plot these results out. All right, so let's move on and touch on composites before we come to the question and answer period. So from a composite standpoint, I spend a lot of time doing composites and composites analysis, and this is probably one of the most exciting pieces of I find in 3D experience, just because that's basically what I do day to day. We do have a great solution in V5 connected to Abacus CAE, but there's some tools that need to be put in place to make that transition happen, to move information from CPD into Abacus. And so a lot of that all goes away in 3D experience. So we now have design and Abacus analysis completely integrated with no need to transfer layups anymore. That's one of probably the key values from my standpoint. We still can use fiber orientations based on producibilities. So your draping simulation will feed into your simulation. But we now also support different ways to move the information across to Abacus. So usually in a layup, we do what's called, we create all our plies, and then we create a layup, in the old V5 and Abacus CAE, we would create, all our plies in CPD, and then push them through a layup file, the plies into the layup file. But now what happens is in 3DEXPERIENCE, we don't even have to have plies generated. If we have a grid model, we can push the grid information directly into our simulation without having the plies even detailed out. And we also support the virtual stacking from the grid, symmetries of plies, which we didn't, and cut pieces as well into the simulation. We can run our typical Sci-Hill, Sci-Woo type failure criteria with shell theory. And we can even take composite properties and map them to external meshes I've gotten from other sources. So an analyst doing composite simulation, they're going to have the CPD model typically created. And then what they're going to do is use this shell section panel to map in their composite properties either through that grid, the plies, ply groups, or zone method, and map those into their model with fiber orientations or cut pieces or symmetries if they're included. So let me jump into a couple files here. So here's a composite model. If you've done composite models in V5, it's basically the same in 3DEXPERIENCE, except I'm using my action bar down here. So what I have here is I have a stacking. And if I expand that out to 2 levels, in that stacking I have plies. So in this case here I have this drop-off area. So I go, full ply, and then I have some drop-offs down to 10 plies, some full plies on top. Okay, and if I take a look at the cross-section, CPD showing me my cross-section, and then we've got that drop-off area down to 4 plies over here. Okay, and inside of those plies, I have my producibilities, which are the fiber directions. And if I do a preview, it might be a little hard to see, but I do have a yellow flat pattern preview, and I have my producibility. And even in 3DEXPERIENCE now, I have this thing called dynamic draping, and I can actually drag my seed point on the model and be updating producibility dynamically. So I can push it right to the edge. And so you can see that I have some yellow shearing here. Well, if I take it and let's just throw it up in the corner here, it's actually showing a different flat pattern because I'm over here producing from this edge, the straight edge, the pattern's straight on this edge, and it's got that joggle on the right edge. If I go into the middle, it's going to have a little joggle here on both edges. So that producibility, which is, the CPD, the power of CPD, one of them is just the ability to create accurate flat patterns and get correct fiber directions. That's going to be pushed over to the simulation. So once I have that information done, let me go into that simulation model. And we'll go into the results. I won't go through meshing here today. We'll probably do a more detailed webinar for composites in the future. But I do have, a displacement plot showing me, the amount of displacement, and then I also can plot out. In this case, I did some frequency modes, so I extracted the different frequency mode shapes. It's exaggerated, but I can see if there's some distortion maybe in drop-off areas and where it could cause, some delamination. We'll go back to the static, and we'll go in and just take a quick look at the Sci-Hill. And you'll see here that in the Sci-Hill plot, the nice thing about it is if I just double-click on it and go into, I can see individually in each ply my failure criteria. So it's pretty minimal here. It's at 0.07 for that ply. Or I can just plot, the max envelope across all plies. So in this case here, I get a 0.15. I'm not close to failure. But the worst case areas are up here, it looks like. And, you can identify those more distinctly with these, these sensors which got created. So if I know that my max envelope that in that area, I need to see, if I want to reinforce this panel and improve the safety factor, then I'm going to have to add material in this region. The question always is, not only where it is, but in what direction does the material go. And there's even a nice plot in here called that plots principal stresses. And so in here now I can see is that the principal stress direction in those areas, see where the red arrows are? They're pointing in that direction. So that's the direction of material fiber I need to add to reinforce. If I added at 90, I'm really not at the 90 to that, I'm really not going to get any effect. So in here you can see I can plot that, and I can increase the density of those if I need to, those principal stress arrows. So you can see if I do want to add more material, I can go back into my PPD model. If I have access to do that in the right license, I'll be able to go in and add some reinforcing plies, update my simulation, and bump up my safety factor. Okay, so let's just jump back into the last slide, and we'll wrap up with the Q&A session if we have time here. So it's just the key messages from 3D Experience in the SIMULIA standpoint. So integrated architecture, same platform, same interface for CATIA and Abacus. No matter what type of role you are, I really showed like designers, engineers, and analysts today, but even outside of those realms, you're going to have the same look and feel interface. You'll all be talking on the same level within your corporation. We've got some newly integrated domains. We're rapidly seeing things like SIMPO be added. I didn't show today, but there's some FE safe technology that's been added for durability. There's EyeSight and the CATIA analysis tools. And we're packaging them based on the type of user and the role they have within specific industries as well. And then finally, I just want to make sure that, so discipline and interoperability. So I want to make sure that everyone understands that simulation is not necessarily going to be just for the simulation analyst. Engineering, C-level, project manager, everyone's going to have access to that type of information so that everyone can make better decisions within their company.